Alright, here we are, number 22. Give the equation in slope-intercept form of the line that passes through, and they give... Alright, so we have to find the equation of a line in slope-intercept form here. What you need to remember is that equations of lines, one of their forms is y equals mx plus b. M is our slope, and b is where it crosses the y-axis, the y-intercept. Well, my goodness, they tell us the slope already. So this line must be y equals 4x plus b. So now we just have to find out what b is. And they've told us one of the solutions, or one of the ordered pairs that are true. In other words, if you plug in an x, or a 2 rather, for x, and I'll do that. Remember, I don't know what b is. But I can plug a 2 in for x. It tells me the y value has to come out to be a 6. And so therefore, with a little bit of math, we find out that the b value has to be -2 for it to go through that point. And that's going to be true then for every single point. And so now we can write the equation of this line. Y equals 4x, and what's the b value we just found? -2. And so there is our solution. Okay, you can check that really quick. It's really simple to check. Slope 4? Yep. If you plug in a 2, does it give you a 6? Well, 2 times 4 is 8, and 8 minus 2 is 6, so yes, it checks. Let's go ahead on this page and look at 23. Find the equation in slope-intercept form, and it passes through at this point. And this time, it's perpendicular to that line. Well, this line has a slope of 2, and we should know, it's a given fact, and you have to memorize it, that if you want to be perpendicular to this line, you have to use a slope that is the negative or opposite in the reciprocal. And remember that 2's over a 1 in the purple there. And so when you do the reciprocal, it's 1 over 2. And the negative reciprocal means that instead of being positive, it will be negative. So now we're kind of like where we were in problem 22. We know this line that we're looking for has a slope that, to be perpendicular, must be -1/2 x, and then it has some y-intercept. Well, what's that y-intercept? Well, whatever y-intercept it takes to force it through -4, 3. So we say, alright, I will plug in 3, I will plug in a 3 for x. Let's get the right thing. And when I plug in that 3 for x, the y value, I flip-flopped my x and y there. I should have plugged in a -4 for x. And when I do that, my y value is 3. Okay? And now I can solve this guy to figure out what b has to be. Well, half of 4 is 2. They're both negative, so it'll be a +2 plus b. And therefore b equals 1. So my final solution is going to be y equals the correct slope, -1/2 x, plus 1. Now again, we can check this. Slope is the negative reciprocal of 2. It's -1 over 2. And I can plug in -4 into this equation right there. Half of -4, or -half of -4 is a 2, and 2 plus 1 is 3. So it checks. Okay, let's go on to problem number, what was that, 25 we're up to next? Oh, 24. Pull 24 up here. Number 24, give the equation of a line that passes through 2, 5, and slope is undefined. Now that's a hard one to deal with because undefined isn't a number. In fact, that means it can't be defined or written as a number. Okay? So what we want to focus on in this case is that if it's undefined, it is a vertical line. If you think about your x and y axis, vertical lines all have the same equation. Vertical lines are all x equals some number, whatever x value it goes through. In this case, it has to go through 2, 5. Okay? That means all the x values have to be 2 because it's vertical. Every single point, if this was the point 5 or 2, 5, then every single point on that green line has to have an x value of 2. And that's what our equation will say. X is always 2. There isn't even a y in that equation because y can be anything, and it does not affect what x is. X is always 2. Moving on to problem number 25. Alright, we have to solve a system of equations. We learned numerous ways to solve these. One of them was to graph the two equations. Another method was called substitution. We did elimination or linear combination. We also did it with matrices. Looking at these two equations, the first thing I would notice is that they are lined up. The x's and y's are lined up with each other, and the constants are on the right-hand side. That leads me to think elimination might be best. So here's my first equation, and I'm going to try and eliminate the y values. So I'm going to take equation 2 times a negative 3. Of course, that's on both sides. I take it times negative 3, and it gives me negative 9x plus 3y equals negative 6. And by using that negative 3, what I've done is cause these y values to be the same coefficient but opposite signs. And so when I add these two equations together, I get negative 7x equals 7 minus 6 is 1, and so x is negative 1 over 7. Okay, so there's my x value. Now I still have to go back and find my y value. I'm going to use equation 2 again. 3x minus y equals 2. This is the form before I multiplied it by a negative 3. 3 times negative 1/7, because I know the x equals 2. That's negative 3/7. So y equals 2. I'll add 3/7 to both sides. So here's the 3/7. I'm going to take that 2 and write it as 14 over 7. So negative y equals 17 over 7, and therefore y is negative 17 over 7. Now, I'm not going to check that, but I certainly would if I had my calculator or if I had more space here. The reason I would check that one is those are pretty ugly fractions, and lots of times in book problems and test problems we usually get some relatively clean answers, but the process is correct, assuming I didn't make any simple numerical errors. Next up, we'll do problem 26. Okey-doke. Another solve the system of equations problem. Okay. Problem 6 again looks like it is set up for linear combination. This time I'm going to take equation 1 times negative 2. This would give me a negative 6x right here, which would disappear when I'm adding it to the second equation, which has a positive 6x. So distributing negative 2 to everybody, I get negative 6x plus 2y equals negative 8. The second equation I leave the same, 6x minus 2y equals 1. I add these two together. Well, the x's disappear like I planned, but the y's also disappeared, so I don't have anything on the left-hand side, equals negative 7. That's a false statement. It doesn't have any variables left, and therefore our answer is the null set. That means there are no solutions. It also means a couple of other things. In particular, it means these two lines are parallel lines, and that implies they have the same slope. So we could put them both in slope-intercept form, and we would find out they both have a slope of 3. Next up, problem 27. It's a long page here of problems. We might be able to get a few done here on this page. Oops, let's move it up just a little bit more. See if we can select all. Yeah. Guess that'll have to be good enough. Problem 27, they want the f of negative 5. So we take the function negative 4x minus 3, replace the x with the negative 5, and evaluate that 20 minus 3. So the f of negative 5 is 17. 28, we want the f of g of x. So f of g of x, we start on the inside. We replace g of x with what it's equal to. And we plug, I'm going to show this with different colors, into f of x. Here's f of x. F of x is 2 times what you're plugging in for x. And in this case, we're plugging in 3x minus 4. So that's our 2x, but x has been replaced with g of x. And then we just simplify that thing down, and that would be 6x minus 8. So notice f of g of x equals 6x minus 8. So we knock off 29 and 30 in this video. There we go. Problem 29, f of x is a linear function. Essentially what they've done here is just given us 2 points. They said that when x is 2, y is 4. And when x is 6, y is negative 8. Now we have to find the equation that goes through those 2 points. First, find your slope. Negative 8 minus 4. Change in y. 6 minus 2 over change in x. Negative 12 over 4. The slope of this line, or this function, is negative 3. The line, like all lines that aren't undefined, equals mx plus b. We know the slope. We just have to find the y-intercept. I'm going to plug in 2, 4 to find out what b is. So what that equation, or what that point says, is that when x is 2, the y value is 4. And we just solved that thing. And I'm finding out b is equal to 10. Okay, so we know b is equal to 10. We know our slope. We can just write the equation. Okay, now let's put this in function notation to be consistent with the question. And lines are functions unless they are vertical. We could check this. You could plug in the 2. Find the f of 2. You get negative 6 plus 10, which is 4. You could find the f of 6. Plug in 6. You get negative 18 plus 10, which is negative 8. So it checks. And then our very last one, 30, is y equals 3x cubed minus 4x plus 1a function. What you do is graph this thing, and I don't have my graphing calculator with me, but it's going to be some sort of shape like this. It will pass the vertical line test, and that's how you know. So yes, that is a function.